Hey, it's JokeBot9000. What awesome joke do you have for us today?
Whoa! How can a robot eat pizza? One bite at a time. I am hilarious.
Yes, you are. Quality work. In this video, we'll look at how we can rig a hard surface robot for animation. We'll create an armature, parent bones to bones, parent objects to bones, and explore common elements for robotic motion, using constraints, custom properties, and drivers to save us time. We'll also look at how we can set up hydraulics without them glitching. And lastly, we'll look at setting up a shader to create an audio waveform effect that is in part driven by a sound file. Okay, we have our robot design made out of separate objects, and we could parent said objects together and then animate them like so. However, this would spread our keyframes out on a per object basis, and a much easier way to do it is to have all of those keyframes under one object, namely an armature. So let's look at creating that and parenting our objects to it. So firstly, we need to designate our root bone, and that can be here in the body, as all other elements will be parented to it. So let's just snap our cursor to the origin of our body here with Shift and S, and add an armature with Shift and A, armature. Now we can't really see anything here until we move over to our armature options and select in front. And while we're at it, let's just switch on axes so we can see the orientation. Now let's snap to our front view here, go into edit mode, select all, and create our pivot points for the remaining articulating parts of our bot. So we need one for the shoulder here, just going to add it here, and scale it down, but making sure we are on active element as our transform pivot, just to give it a little bit of visual distinction. Let's Shift D and move it up, and we'll have one for the head here, and we can place it here. And just to make sure we are right in the center, let's hit N on the keyboard and move the head of the bone as 0 on the X and 0 on the tail. Now this bone can control the overall orientation of the head, but we also want to spin the head 360 degrees. So in order to do that, we really need an offset bone, as, moving the hydraulics here 360 degrees is going to tangle all kinds of stuff up. So let's just Shift and D and move it up like so. Okay, one more here along the center, and that's for the radar. And we can move on to the eye. Okay, so we'll do Shift and D and have one here for the pupil. Again, scaling it down. Shift and D for the lower lid and upper lid and eyebrow. Now we need one more here for the ear. And in order to align this correctly, we're just going to drop it somewhere off on the side, jump into object mode, select this element, snap our cursor to it, go back into edit mode for our armature, and this time snap the selection to cursor. Now we can rotate it 90 degrees and scale it up a little bit, and then zoom out and have a look. Oh, as you can see, we need to adjust the position of our eye bones and eyebrow bone. So let's go into wireframe and snap on over here to the X-axis, hit G and move it along the Y, like so. Okay, back to material view. We can see the only remaining elements really to do here are the hydraulics. And this is slightly more of a tricky setup, so let's look at that now. Okay, we need a bone per section here. So firstly, we can snap our cursor on over to the selected element here, go into our armature, into edit mode, and then just hit Shift and A to add a new bone. Back out into object mode, we can select our second element, snap our cursor to it, go back into our armature, and for the tail here, we can snap selection to cursor. Now selecting this bone in its entirety, right click, we can click subdivide, so we have two bones, and this one we want to flip around, so right click, switch direction, and we want to separate it so it isn't in a hierarchy or it isn't in any child-parent relationship. So Y on the keyboard, and then if we move up to our pivot point options and select individual origins, we can hit S with both selected and scale them down like so. And now we have a bone for each section, and we can also, with constraints, point this bone to this bone and vice versa. However, that doesn't strictly work as we create a dependency loop. And in order to break that, we need to introduce one more bone. So let's just select the bone down here, Shift and D, right click to drop, and scale it down, just like that. Now jumping back out to object mode, let's select these two bottom parts in order to snap our cursor into the center. And this just gives us a point in space to mirror these bones around. So let's just select the bones we just created, go up to our pivot point options here, select 3D cursor, and then Shift and D, right click to drop, Control M, and then Y. All right, now we have our bones fully set up for one side at least. So let's just go in and rename them. So into edit mode, F2, let's call this one body, head, offset, radar, ear, shoulder, and over to the eye, brow, upper lid, pupil, and lower lid. Okay, we don't really need to name our hydraulics here as they're going to be fairly passive. Okay, now we have all of one side, we can look at creating the hierarchies we need to. So in order to do so, firstly we want the head to be connected to the body here. So let's do Control and P, and we want to keep the offset. And we want our offset head to be connected to our head, Control P, keep the offset. Shoulder connected to the body, Control P, keep offset. We want all of the eye, as well as the ear and radar to be connected to our head offset. So Control P, keep offset. And our hydraulics here. We want these two bones to be connected to our head, Control P, keep offset. These two bones to be connected to our body, Control P, keep offset. And the smaller bones connected to the larger bones. Control P, keep offset. Control P, keep offset. Now, in order to mirror everything over here, we could use the mirror command, or if we were to add a suffix to it, like so selecting our bones, hitting Control and F2, and then batch rename, we want to select bones, and we want to, instead of find and replace, we want to set name, suffix, and our name we want is _L. Now we can click OK, and all of those bones have an _L suffix now, which affords us the ability to select them all and go to armature and symmetrize. Now, if we jump into pose mode with Control and Tab, pose mode, we can quickly check our rig. So rotating it, let's just switch on over to active element. Okay, head, everything follows nicely. Body, excellent. And because we did symmetrize, we can also take advantage of things like mirroring pose along the X, which is a pretty handy feature. Okay, with all of our bones parented, it's time to parent our objects to said bones. Okay, let's get parenting our objects to the bones. Now, in much the same order, we can start with the body here. So selecting all of the objects, shift selecting our armature, going into edit mode and selecting our body bone, then going back out into object mode, Control P, and just parenting directly to the bone, like so. And here we can do the same, selecting our bone, Control P, bone, the same the other side, like so. And for the head here, we only want these two elements, as we want to retain the ability to rotate this section 360 degrees. So these two elements can be parented to our head bone, Control P, and everything else, at least temporarily, can be parented to our offset bone, Control P. As you can see, we can rotate one like this, and this one is free to continually rotate like so. Okay, continuing on. We want our radar element here to be parented to this bone, Control P, the ear element to this bone, Control P, and likewise this side, Control P, eyebrow, other eyebrow, and this time we can hide this section here, select our pupil, and parent it to the associated bone. And after a while, this somewhat odd pattern of keyboard strokes, of keystrokes, becomes a bit more fluid. All right, let's just do a little test in pose mode. Okay, looking good. Oops, something didn't take there. Probably a little bit fast on the keystrokes. Excellent. Okay, cool. Now, in order to set up our hydraulics here, we can go about it in much the same way. Parenting the lower section to the larger of the bones we created. Excellent. Okay, we're ready to start setting up some constraints. Meanwhile, I will try and constrain my excitement for launching the Robot Planet course. If robot creation is your thing and you want a deeper dive into the process, then there is a link in the description to start your journey. Anyway, back to the video. Okay, we have our objects nicely parented to our bones, but we want to set up some constraints, some boundaries where it becomes easier for us to animate within. And to do so, we can start with our ears, as we only really need to rotate them across their local y-axis here. So in order to do so, with that ear bone selected, we can go over to our bone constraints, add bone constraint, and just limit the rotation. And as this is the Y, we want to limit the X and the Z. And we don't want it in the world space, we want it in the local space. So now we can rotate our ear simply by hitting R, and no other axes will rotate. Okay, now for the hydraulics, which are a little bit more difficult to set up. So firstly, we want the base here to point to the top part. So let's start by selecting the top part, shift selecting the bottom part, and we can use Control Shift and C and select damped track. Now, in order to not create the dependency we spoke about before, we can select the smaller bone here, then Shift select the top part, Control Shift C, and damped track. Let's just test it and see if that has worked. Yes, that's worked great. So let's just continue that idea with the other three hydraulics. So selecting the top, Shift selecting the bottom, Control Shift C, damped track. Smaller bone, top, Control Shift C, damped track. As you can see, this comes together quite quickly. Okay, let's just test that out. Excellent, that's looking great. Now let's continue to automate things a little bit with custom properties and drivers. Before we start adding drivers, firstly, we need to address the fact that these rotations are all set to quaternion. Quaternion is great for being able to rotate and not have any gimbal lock. However, for us, because we're going to want to rotate multiple times, 360 degrees or more, we need to switch over to using an older method. So if we select all of our bones and Alt and click our quaternions here, we're going to switch over to XYZ Euler. And that affords us the ability to continually rotate past 360 degrees basically forever. And that's exactly what we're going to do with a driver. Now, in order to add a driver, we can click in, and then for a scripted expression, hit hashtag, and we're going to use frame, which is just the frame number. So when we hit play here, you can see that our radar spins around, converting the frame number into Euler radians, the way Blender stores rotational data. However, it's spinning particularly fast, so we want to be able to control that rotational speed. So if we jump back to frame 1 here, go into edit mode, select our radar bone, and we're just going to duplicate it and move it up. Alt and P, clear the parent, and rename it with F2 to control, all uppercase, because it's extra important. Now, if we go over to pose mode and we select our bone properties, you can see we have the option to add custom properties. Now we can click new, and once more, and one can be our radar speed, okay, and the other one can be our robot voice. This we will use slightly later. Okay, now you can see those properties have appeared in our side menu here, which you can see by hitting N and going to item. Now, how do we go about using our variable here within our newly created driver? Firstly, let's select it, right-click on that variable and copy the data path. Now let's go to our radar bone, right-click it, edit driver, and we want to create a new input variable. So let's click that, select our armature, and the path here we can just paste in from our control bone. Now it has that variable and it's referencing it as VAR for variable, and we can use it in our expression. So to do so, we want our frame number and we want to multiply it by our variable. And with that done, if we hit play here, we can jump into our control bone and change our radar speed down to 0.1 or 0.2. I think 0.2 is quite nice as a sort of idle speed. And with that done, let's progress to hooking up arguably the hero visual for our robot piece, and that is the mouth waveform. Okay, we have our robot nicely rigged, but the only thing we don't have is a nice waveform effect for the mouth here. So I am going to select it and drag out a new window, which we can change on over to Shader Editor. And if we jump over to our Shader Editor options here, we can just rename this mouth for continuity. Now over in our Shader Editor window, we can hit N to hide that sidebar, and also the home button just to focus on our shader. And as you can see, it's fairly basic. And what we want to do is create a nice luminous line that goes straight through the mouth here. Now we can do that with a gradient texture. So if we plug that gradient into our emission strength, give our emission strength some kind of color, maybe something like that, you can see that we are affecting, based on our gradient here, the emission strength. By the way, I'm using Control Shift and left click here to hook up temporarily to the shader so we can see it. If you can't do this, you may need to go into Preferences, Add-ons, and enable Node Wrangler. Okay, moving on. Now, in order to create a line, we need to address halfway through our gradient here. So if it's from 0 to 1, we need 0.5. So we can do that with a math operation. And the operation is compare. And let's just plug that in. And as you can see, we already have 0.5 as our value here. And the epsilon could be considered a threshold or a deviation from that. So if we turn that way down, you can see we now have a line. But we want to distort the line. So we can do so by affecting our vector input of our gradient here. So if we hook up that, firstly to a mapping node, we want to affect the up and down coordinates, which are, let's just check, which is X here. So let's drag out from our location, and the node we want is combine XYZ. The value we can address is our X here. However, our line is gone. We need to hook up a vector into our mapping node, and here we just want our standard generated coordinates there. I can minimize that. Okay, let's take advantage of a noise texture to displace our mouth into a waveform shape. So I'm just going to drag out from the X here, search for noise texture. You can see it's already kind of doing something. However, we want to affect the range of values this noise texture is spitting out. Firstly, we want to keep it quite basic, so I'm just going to delete the roughness and the detail here. And then we can search for a map range and plug that in. Now our noise texture has pushed everything a little bit far down on the x-axis, so we're going to use our minimum value to -1 to bring it up a bit, and tweak our from, min, and max values until we're happy with it being kind of central. Now so far our noise texture is distorting it in a way that makes it very wobbly, and this is because it is effectively moving those pixels along multiple axes, as we can see here. And we want it to just move it up and down along the x-axis. And in order to do that, we need to affect the vector of our noise texture. So again, we can hook up the vector here, or, assuming you have that Node Wrangler add-on engaged, hit Ctrl-T for an automatic chain to appear. Now with our scale here, we can reduce our X scale down a lot to 0.1. I'm just going to increase our noise texture scale here, and you can see the effect that's happening. Let's go to 0.01. Now we kind of only have the noise texture along our y-axis here. So if we were to again look through our principle, you can see the effect we're having, and this is exactly what we want. Well, nearly. We kind of want it to gradually increase into the center and then fade off again toward the edge. And we can do that with another gradient node. So let's just load up a gradient node and look through it there with Control, Shift, and left click. And this isn't the axis we want. We want it to appear along the y-axis. So we're going to have to rotate it. Can do so with our good friend Control and T to hook up coordinates. And as we have X up and Y, we know that Z is front to back. So let's just rotate that minus 90 degrees. Perfect. And we can use another math operation here, affectionately named ping pong, to convert this gradient into another gradient, but this time with the 0 value reaching up to 1 at the halfway mark and then reducing back down to 0. Like so. Okay, so how can we use that within our shader? At the point in which we are plugging into our combine here, we can just add a math node set to multiply and plug in the output of the ping pong variable here. And just because I don't think it looks totally right, we're going to refine it with a color ramp. So we can choose to have quite high values that roll off like so. Okay, that's all well and good, but if we were to hit play, nothing happens really. So we need to offset our noise texture. And to do so, I mean, we could do it with the vector input here, but we're just going to switch the noise texture over to 4D, which enables this W input over time. We shuffle back and forth here, you can see the effect. And in order to automate that, we can drag out here and just type in value. And within our value, we can do, for a scripted expression, hashtag frame. And if we jump out of that, you can see it matches our frame number and shuffles along like so. And if you're not entirely happy with the speed, you can always adjust the value by, let's say, dividing it by 50, and that gives a bit of a smoother effect. Now that looks good, but it doesn't react to any audio, so let's look at that next. In order to link this shader effect to some audio, first we need to import some audio twice. First, in order to hear it, and secondly, in order to have curves that we can reference in our shader. So in order to hear it, let's just switch our shader editor over to Video Sequencer. And now, with our playhead all the way back to frame 1, holding Shift and left arrow key for that shortcut, we can go up to Add, Sound, and select the audio file we want. Now we can see here, if you hit N and display waveform, we can see our audio nicely, and when we hit play,
Whoa! How can a robot eat pizza?
You can hear it. And while we're at this point, it's always good to mention the sync option should be on sync to audio. This is so Blender knows to align the frame, even if it has to skip them with the audio. Okay, let's look at importing that audio file into our shader. Firstly, we can select our armature, go into pose mode, select our control bone up here. I'm just going to hit N on the keyboard. And here we have our robot voice, which is just a value set to 1, but we want to create a key. So just I over that. Switch our video editor to graph editor. Just make sure we have selected robot voice here in our channels and go up to channel, bake sound to F curves. And now we can select our audio file again and just bake sounds to F curve. Now we have the audio represented as a curve in our graph editor. And in order to bring this into our shader, we can go over to our custom property robot voice here, right click, go down to copy as new driver, jump back on over to our shader editor, selecting our mouth here. We can add a new value node, right click it, and paste driver. Now we have those values from our custom property in our shader. Let's just hit F2 and name it voice. And now we can use this value as a multiple for our noise texture. So again, let's load up a math and change it to multiply, plug it in between, and use our voice as the value. And now when we play back...
Whoa! How can a robot eat pizza? One bite at a time. I am hilarious.
It's looking a little bit weak there. So I'm just going to duplicate that multiply node and just crank it up to 2.
Pizza. One bite at a time. I am hilarious.
Excellent. Okay, we have a nice simple rig that we can easily animate with. However, we have only really scratched the surface of the optimization and organization that Blender's tools offer. If you're interested in learning more, you can always jump on over to CG Boost, where we cover these tools in much more detail, as well as lots of tips and tricks for actually animating robots. I hope to see you there.